Okay, so here's E3. So we're going to find the derivative using chain rule. I'm just going to do two quick examples. This is number 5 from the practice. So you don't need to do number 5 from the practice unless you want to do it again. But this is number 5 from the practice. So it asks you to find the derivative with chain rule. So, and guys, in the future, like down the line, you're not going to be told which rule to use. But we will talk further in the future about why we need chain rule, like how to spot a function that you need to use chain rule for to find its derivative. So because we need to know that in the future, as you're doing these problems, you're going to do a bunch of them until they're really fast. Just be asking yourself, like, why is this chain rule? You know, like, I'm telling you to use it, but like, try to pick out like clues of why we would need to. So, all right, the inside function, 4x squared plus 7x. So you're looking inside of parentheses or under a radical for the inside function. And then the outside is 3 blank to the negative 2. If you need to go a little bit slower, you know, you could do like a little aside if you want, where you have like 3 over u squared, u instead of a blank, and then that's, you know, 3u to the negative 2. All right, so to the side, you could think of it with a u instead of the blank, and it might be easier for you to put it in the form a blank to the n. All right, the derivative of this inside is 8x plus 7. And then the derivative of the outside is negative 6 blank to the negative 3. And then what goes back in the blank? What goes back in the blank is what used to be in there. Okay, so the blank remains the same. What's in the blank remains the same from the beginning to the end. So 4x squared plus 7x. All right, and then I'll just write it with, you know, the coefficient out front. Okay. So there's that one. Now let's do this one. So, doing the same thing. So I'm looking for inside of parentheses or under the radical. Here I have both things going on. So I have this inside of parentheses, which is also under a radical. And then this is 4/9 blank to the negative 2/3. Okay, and again, I will say, if that is difficult, think of this as 4/9 u to the 2/3 maybe. All right, and you will see quickly that that's 4/9 u to the negative 2/3. But this is optional. So let me write optional. Optional aside. That's for if you're trying to figure out the outside function. Okay. And then 4x. I'm not taking the derivative. All right, I take the derivative of the inside. Oh, it's the same. 8x plus 7. And then the derivative of the outside, so 4/9 times negative 2/3 is negative 8/27 blank to the negative 5/3. And then what goes back, what used to be in the blank is this, so it goes back there. 4x squared plus 7x. All right, let me just bring the coefficient in the front. All right, guys, so I'm asking you to do a lot of these because that's what it takes. We don't just want to know how to do these. We want to be fast at them, super, super fast. Because eventually we're going to be doing these very deep conceptual problems. We're just, for most of the year, we're just building skills until we're ready to put all of those skills together to tackle some really tough, challenging problems. Okay, so if I'm giving you a lot of problems and it seems like, oh, this is the same thing over and over, it's because that needs to be so fast and it just needs to be automatic. And this is the way you develop those skills to be fast and automatic, is that you just do them over and over and over. All right, I'll talk to you later.